So this morning, we are just covering the first part of section 2.8, function operations. And notice what that's saying. We can take two different functions, we can add them, the functions themselves. We can subtract them, we can multiply them, we can divide them. That's what we're talking about today. Tomorrow we'll be talking about composite functions, totally different thing. Now, this is in the textbook. Let me just point out, don't write it down. It's in the textbook. Let me just point out a couple of things. It's saying we have two functions, f and g. We can add them. And notice what it's saying there about that. If we add two functions, look at the notation. It looks like that. What does it really mean? Just add them together. Look at the subtract. What does it mean? Just subtract them, and so on. Now notice with subtraction and division, the order that they're in makes a difference, just like it does in all algebra. But just get used to that notation. It's different. Then down here at the bottom, I want to point out a couple of things. It says the domain, we got to get into that, includes all real numbers in the intersection of the domains of f and g. We don't maybe know what that means yet. And in addition to that, the domain of f divided by g, you got to be careful so that this bottom number down here, this thing is not zero. That's what this is saying. So you've got an extra thing to check for on the division problems. So the add, subtract, multiply, and divide, they're just like any other add, subtract, multiply, and divide. It's just with functions. And then with the domains, we got to see about their intersection, so we'll know what that means. So let's talk about the intersection then. I'll let you jot this down. So here's how we figure out what the intersection is. I would suggest doing a little number line. And then look at the numbers involved in the problem here. So I'm seeing a 0. I'm seeing a negative 20. I'm seeing a positive 20. I'm seeing positive infinity. So that's going to be out here someplace. And then we're just going to sketch those intervals. See, I've got two intervals. I want to see what their intersection looks like. So for the first interval, it's going from 0 to infinity. But notice it can't include 0. It can't include infinity. So I'm just going to diagram it like this. There's that first interval. There's my red one. I'm going to take the second one, we'll call it the blue one, and it's going to go from negative 20, but not including negative 20. It's going to go all the way up to 20. And the intersection, anybody know? It's where they overlap. Yeah, just exactly like the man's saying. So they overlap in here. That's what the intersection is. So the resulting domain then would be what? Not including either of those. There's my answer. So doing this little diagram, I think, will help just visualize it, because sometimes it'll trick you. Why do I bring this up? There's going to be some problems in the homework like it. Let's do another one. Okay, so I'll draw my number line again. I'm seeing -4, 2, 3, didn't make it long enough here, 10, positive infinity, negative infinity. So I'm seeing all of those values here. So notice the first one here is a union. So it's going from -4 to 2. Unioned with 3 to 10. So there's a diagram of that first interval, if you will. Then this one is going to just be everything. Where do they intersect? Yeah, now notice something. If you are finding the intersection of negative infinity to positive infinity, like the blue one there, with something else, it's always just going to be the something else. Always. So here, the interval of the domain would be what? -4 to 2, union 3, 10. In other words, just like the first thing. Because I'm seeing, where's the overlap? Well, it's that first interval. All right, let's keep going. So I got negative infinity to 0 and 0 to infinity. And notice these are open intervals. We're not including the endpoints. So number line, I'm seeing 0. I'm seeing negative infinity, positive infinity. My first one is going to go from negative infinity to 0. My second one is going to go from 0 to positive infinity. Now, do you have to do it this way? Of course not. But I think the visual will help you see what's going on. Where do they overlap? You sure? Neither one of them includes 0. There is no overlap. There is no overlap here. See, if these two things here were closed dots, then yeah, 0 would be the only overlap. But here, they're open, so there is no overlap. So what do I say? The empty set. There is no overlap. The null set. One more, and I think maybe it'll help you understand. All right, once more, number line. I'm seeing negative infinity, 5, 1, infinity. This one goes from negative infinity to 5, but not including 5. And this one goes from 1 to infinity. Where's the overlap? Well, right here. So I've got what? 1 to 5. And again, why am I bringing this up? Well, way back here, down here at the bottom, it says the domain of all of these different operations are the numbers in the intersection. So once we get a result, they might ask us, what's the domain of that result? That's what this is talking about here. Okay, question about that? So that's really what we just got through talking about. Is just leading into that definition they put down there on that very first page. All right, so let's look at a couple of these. So here, pay attention to the notation. This is saying we're going to add these two functions together, and then we're going to evaluate at x equals 0. That's what that notation is saying. So the first thing I want to do is add them together. So I'm going to say, all right, 3x minus 4, and I'm using parentheses, plus 2x squared minus 1. I take off the parentheses, so I've got 3x minus 4 plus 2x squared minus 1 equals 2x squared plus 3x minus 5. And then I'm going to evaluate that when x is 0. So 0 squared, my first term, is 0 times 2 is 0. 3 times 0, 0. Minus 5. So I'm just getting minus 5. Double check and see if that's what you're getting. Thank you, ma'am. So in other words, just to make sure, if I add those two functions together and then evaluate the resulting function at x equals 0, I get a y value of just negative 5. That's all that's saying. That was add. Let's do a subtract. And again, I advise you to start off with parentheses around these things, especially on the subtraction ones, because signs will change. So I've got minus g, which is 2x squared minus 1. So I've got 3x minus 4 minus 2x squared plus 1. Watch those signs. They get me all the time. So I've got 3x, and let me start with my squareds. I've got minus 2x squared plus 3x, negative 3. I'm going to evaluate that where x is 4. So here, 4 squared is 16 times negative 2 minus 32. X is 4 times 3, that's 12 minus 3. So negative 23. Minus 35 plus 12. Notice something else. The order matters here because we're subtracting. If this were G minus F, it'd be totally different. Note to self. Okay, add, subtract, let's do a multiply. And I just wrote the functions up there at the top because you've already got them written down, but if somebody's watching this video, they might not realize it. So I'm going to multiply these. So I've got 3x minus 4 times 2x squared minus 1. So I've got 6x cubed minus 3x minus 8x squared plus 4. I'm just putting this in standard form here. I don't guess you have to do that. Just makes it easier to follow. All right, so then I'm going to evaluate at negative 2. So I've got negative 2 cubed, negative 2 squared, just negative 2 there. So negative 2 times negative 2 times negative 2 is negative 8. Times 6 is negative 48. Negative 2 squared is 4 times negative 8 is negative 32. Negative 3 times negative 2 is negative 6 plus 4. So negative 48, negative 32 is negative 80. Wait. That should be a plus 6, shouldn't it? Negative 3 times negative 2. Okay, so negative 48 times negative, plus negative 32 is negative 80, plus 10 equals negative 70, I think. Double check me. Yep. Now think about this. If they wanted us to evaluate this and the bottom value came out to be 0, we got a problem, right? Okay, so let's see if we can solve this thing. So I put f on top, so I've got 3x minus 4 divided by 2x squared minus 1. And what I'm saying is, if that 2x squared minus 1 evaluated to be 0, we got a problem. I don't think that's going to happen when we're saying, okay, evaluated at 3. So I've got 3 here. I've got 3 here. So on top, I've got 3 times 3, 9, minus 4. On the bottom, 3 squared is 9, times 2 is 18, minus 1. So I've got 5/17. Sometimes you're going to get a weird answer like that. Perfectly good number, though. Now, how else could they get this point across to you, you might ask? Now they're just saying, find the resulting function. I think this was 4x minus 1 out here or something. They want us to find the resulting function and then find the domain. Okay. See, they're not saying evaluate it at anything. They've just left it as x here. So what am I going to do? I'm going to say, all right, I'm going to add these together. Like that. Now, if we did the same thing that we started class off with and said, all right, what is a domain? Let's just say that's 0, negative infinity, positive infinity. For my f up here, What's the domain of that thing? Is there any value x cannot be? No. So it's going to go every real number. For this one, anything x cannot be? No. It's going to be the same thing. Where do they overlap? Everywhere. Here's all my overlaps. So the domain of this thing would be negative infinity to positive infinity. There is no value that the result cannot be. Said another way, that result is valid for any x, all real numbers. Let's go on to this one. Another one is to subtract. So, x squared minus 3x minus 4x plus 1, minus 1, sorry. So I've got x squared minus 3x minus 4x plus 1. So I've got x squared minus 7x plus 1. So in the homework, this is going to be one of those two-part things. What's the resulting equation, and what's the domain? Well, we're still talking about the same f and g functions. We already decided the domains of each of those is from negative infinity to positive infinity. That means the overlap is everywhere. So the domain's going to be same as it was above, right? Just subtracting them doesn't change that. You think multiplying will? You think division will? Let's see. Here's multiply. This is still 4x minus 1 out here. All right, so I put x squared minus 3x times 4x minus 1. I get 4x cubed minus x squared minus 12x squared plus 3x x cubed minus 13x squared plus 3x. So there's my resulting function. The domains of f and g are still the same. They overlap every place. So the domain is going to be, just as we've seen, that. It's just a real methodical kind of thing. Once you get comfortable with the notation, then you've done stuff like this before. Maybe not exactly like this, but you've done similar things. So I've got x squared minus 3x over 4x minus 1. There's my answer. What's the domain? Now, don't get lulled into thinking, okay, those first three examples in this right here, the domain was negative infinity to positive infinity. Because F and G, that was their domains. But let's go back to here. What do we have to watch out for on divides?
Zero.
Yep. Okay, so if I diagram this like we did before and said here's 0, here's negative infinity, just like we've been doing, then F would have this, G would have this, but what can X not be? How do you decide? You say, well, all right, 4x minus 1, set it to 0, because 0 is what I don't want it to be. So then 4x equals 1, x equals 1/4. Is that what you said?
Yeah.
Well, you are exactly right. So in purple here, it goes from it's positive 1/4. So here's 1/4. Got to leave that one out, and then it goes out to here. So the purple down there at the bottom is the diagram, if you will, of the domain of this result. See, this thing right here has a domain of negative infinity all the way up to, but not including 1/4, union starting at just beyond 1/4 and going to positive infinity. The division one has that extra caveat, if you will. Make sure the bottom's not 0. Now, how else could they ask you this sort of stuff? Well, they could give you a diagram. I'll let you sketch that out just so you'll have it. These are not bad. What are we going to do? This is telling us we want to add those functions together and then evaluate the result at 1. Well, we can look at the diagram there. What's F at 1? When x is 1, what's F? When x is 1, what's F, the red one? 3, right? What's G at 1? One. Add them together. 4. That's my answer. They're not really telling us what F and G are. We know that G looks like the absolute value function, that F looks like a parabola. But what we're doing is kind of backwards here. We're saying, okay, evaluate each one of those at the x points, and then do what the thing is asking you to do. In this case, add. How about this one? Subtracting here, so I've got F at 0 now. When x is 0, what's F? 4, thank you. What's G at 0? 0. What's 4 take away 0? Well, 4. Okay? We're multiplying and evaluating at -1. When x is -1, what's f? What's g? I'm with you. So I'm multiplying 3 times 1. Here's just a different way they're going to ask you. Same concept, though. Let's look at a divide one. F at -2. I'm seeing 0. G at -2 is 2. Zero divided by 2 is 0. Okay, so there's another way they can ask you, and will. Oh, but they're not done. How else could they ask you? With a table. Now notice they're just saying, I want these two functions added together. Now we sure don't know what the functions are because they just give us a table of x and y values. And they're saying, add them together and evaluate at 1. Okay, similar to what we did last time. They want us to add the functions together and evaluate at 1. So what's f at 1? Okay. What's g of 1? 6? I'm getting 7 up here. These are the kinds you want to see in 2.8. Let's do a subtract. And we're going to evaluate at 0 this time. So f at 0 is -1. G at 0 is 4. So I've got -1, subtract 4, -5. Let's look at a multiply then. All right, so I've got, and we're going to evaluate at -1. So f of -1 equals -3. G of -1 equals 2. -3 times 2, -6. Y'all seen how it works? Let's do a divide. So I've got f at -2 is -5. G of -2 equals 0. -5 divided by 0 is not happening. It's undefined. So if we got into Desmos, for instance, and we put those functions in there and divided them, something's going to go off the charts at -2. It won't exist. Okay. How else could they ask this? Just by giving you two functions and saying, add them together, evaluate at 1. Or could we do it a different way? Now see, this right here, we already did something like this. Could you do it a different way? Well, yeah, you could evaluate first if you wanted to, couldn't you? So look at F. When I plug a 1 in for X, I've got 3 times 1 is, in other words, here's F. I've got that, plus, just plug it in as you go, plus minus the absolute value of 1. So on the first one, I've got 3 times, so I've got 7, plus the absolute value of 1 is 1, but minus it. So I've got 6. I don't necessarily have to figure the whole thing out if they're asking me to evaluate. Now, if they're asking me to give them the resulting function, then yeah. But they just want me to evaluate here. Let's do a subtract. And we're evaluating at 0. So I've got 3 times 0 plus 4 minus this, minus the absolute value of 0. So 3 times 0, 0 plus 4 is 4, minus the absolute value of 0 is 0. Take the negative of that, it's 0. Take the negative of that, it's 0. I'm just getting 4. Again, this works when they're just saying evaluate it. You have to read the question. Here's multiply. So I've got 3 times negative 1 plus 4 times negative the absolute value of negative 1. So back over here, 3 times negative 1 is negative 3 plus 4 is 1. The absolute value of negative 1 is 1. And then the negative of that is negative 1. So 1 times negative 1, I'm getting negative 1. Double check my math. Last one, y'all. We're dividing and we're evaluating at negative 2. So on top, I've got 3 times negative 2 plus 4. On the bottom, I've got negative the absolute value of negative 2. Okay, so I got negative 6 plus 4. The absolute value of negative 2 is 2, but then that minus in front, so I've got negative 2 here. So on top, I've got negative 2. On the bottom, I've got negative 2. I'm just getting 1. So make sure you read the questions. If they're just saying evaluate, you can do it like this, as opposed to the way we did it here. Now see, on this, they probably said, well, what's the resulting function? And then evaluate it. So just make sure you read the question. That's it for me, unless somebody has a question. All right.